Hey guys, welcome to a new video. Today's problem is categorized as easy and the problem is reverse first k elements of the queue. Let's see the problem statement. Given an integer k and a queue of integers, we need to reverse the order of the first k elements of the queue, leaving the other elements in the same relative order. So we are allowed with some standard operations on the queue, that is enqueue, dequeue, size and front. There is a note given. The above operation represents general processing inbuilt function of respective languages can be used to solve the problem. So let's quickly see the example to understand the problem and decide how to approach this problem. So this is our first example where we are given with 5 elements, that is 1, 2, 3, 4, 5, and the k value is 3. So according to the question, we have to reverse the first k elements, that is first 3 elements. So if we reverse the first 3 elements, 3, 2, 1, and rest of the array elements will be kept as it is, that is 4, 5. So this is our expected output. Now let's see how we can get this result. So to solve this problem, we need to take help of a stack. This is our given queue. The elements are 1, 2, 3, 4, and 5. So what we will be doing is we will pop out all the k elements from our given queue, that is these 3 elements, and push them into our created stack. So if we push the first element, that is 1, and the second element is 2, then we will push the last element, that is 3. Now our queue will be left with 2 elements, that is 4 and 5. So we need to add all these elements which are present in our stack right now back to our queue. So we will simply pop out all the elements from our created stack and enqueue in our original queue. So at first the top element, that is 3, will be enqueue. Then the second element will be enqueued in our queue, and then we will enqueue the last element of our stack, that is 1. So our updated stack will be empty. No elements are there. So by now we can see we have reversed the first k elements of our original queue. That was 1, 2, 3, 4, 5. We have reversed as 3, 2, 1. First k elements are reversed, but we have to maintain the order of rest of the elements. So if our length of the queue is n, so how to find the length of the elements which are required to be kept in same order? So we will simply subtract k by our length of the queue. So n minus k will give the rest of the elements which are required to be kept in a similar order. So for this rest of these elements, we will simply dequeue it from the front of our queue and enqueue at the rear position of our queue. So in the second step, our queue will be this: 5, 3, 2, 1, and 4. Similarly, we will perform for this element. We will dequeue from the front and enqueue it at the rear. So our final queue will be 3, 2, 1, 4, and 5. And thus we have achieved our expected output. So we have made our problem easier using a stack. So if we talk about the space and time complexity of the problem, we have used a stack which will store the first 3 elements of our queue only. So the space complexity is big O of k, while the time complexity will be big O of n if the size of the queue is n, because we are iterating through each of the element in our queue. Time complexity is big O of n, and thus we have met our expected time and space complexity, that was big O of n and big O of k respectively. So now let's jump into the code quickly. At first, let's store the length of our queue. Now, as we have discussed, we need a stack to solve this problem. So let's create a stack of integer type. Let's name it as S. Now we have to push all the first k elements from our queue to our stack. So for that, we have to run a loop till k is equals to 0. We will iterate and we will take the first element of our given queue, that by q dot poll, and this element is need to be pushed in our stack. So simply we can write s dot push. So q dot poll is an inbuilt function, and after pushing a value in a stack, we will decrease the value of k. Thus it will iterate for k number of times. Then we are ready with our stack. Now as we are ready with our stack, we will pop out all the elements from our stack and enqueue in our original queue itself. So for that again we need a loop where the loop will run till our generated stack is empty. So we will check while s dot is empty. This function checks whether our stack is empty or not. So we will iterate till our stack is empty. We will enqueue all the elements present in our stack to our original queue. So for that we have another method queue.offer, and we will enqueue the top element of our stack. So we can get it by s.pop method. So by now we have reversed the k elements, the first k elements of our queue. Now we have to find the length of the remaining elements which should preserve their order, or their order must not change. So int rem is equals to the length of our queue which is stored in n minus the value of k. And now we will iterate till our rem is greater than 0. So here, as we have discussed, we will dequeue an element from the front and enqueue the same element in the same queue. So to add the element we will use queue.offer, and for the dequeue operation we will use queue.poll. That will bring out the first element of our queue, and after each operation we will decrease our rem. Thus all the remaining elements will get back to their original positions, and after performing all the operation we will simply return our resultant queue. This is all about the code. Let's quickly compile and run. Okay, so our code compiles fine, but there is a wrong output. The reverse part is okay, but the rest of the elements are not at the specific position. So we have encountered this error because we have calculated our rem at this position and we have decreased our k in the first while loop. So we have to calculate this remaining element at the beginning, and now if we compile and run, the code is compiling fine and we are getting a right output. So if anyone is unaware of this function, that is queue.poll or queue.offer, they can use queue.front instead. Queue.front function will return the front value of the queue, and in this case you need to pop out the value, so you have to use queue.pop function also. And I hope everyone is familiar with push function of stack. And in the next loop here we used pop. Basically it returns the top element of our stack, so you can write s.top as well. So in the next iteration s.pop, the pop function will pop out the top value from the stack, and queue.offer is an inbuilt function which will enqueue the element or push the element. So in place of queue.offer you can also use queue.push. We have discussed all these function. So now let's submit our code. Yeah, so it passed all the given test cases. I hope this video makes the problem more simpler and easier to solve. And if it is, please like, share and subscribe our channel, and let's get back in the next video.